Alrighty, let's go ahead and do another example of the application of the sum formula. And this time we're going to try to find the sine of the sum of arc sine of x plus arc cosine of x. All right, so let's do the same process that we did last problem. I'm going to let my first term right here equal u, and let my second term right here equal v. So really we're finding the sine of u plus v, and I'm just going to go ahead and write the sum formula down here, and then we'll just go ahead and plug it in. We're going to be finding the sine of u times the cosine of v plus the cosine of u times the sine of v. All right, so what we want to do here is, so let's let u equal arc sine of x. Okay, so let u equal arc sine of x. So on the both sides, what I want to do is take the sine of both sides. And this is because I want to get rid of the arc sine. So if I take the sine of the left side, I get sine of u. If I take the sine of arc sine and arc sine cancel out, and I get just x. All right, so we can create a right triangle from that information. And that was probably the most horrible triangle that you've ever seen in your whole life. So let me try that again. All right, let's see here. Oh, yeah. Oh. Oh. Ah. Okay, there we go. Right triangle there. Probably the worst 90-degree angle you probably see now. And this is my u. So sine is opposite over hypotenuse, so that's x over 1. If I want to solve for this side, it's something squared plus x squared equals 1 squared. So that means I bring the x squared over, so that's going to be the square root of 1 minus x squared. Okay? You could do a little more work there if you want to make this side equal c, and then you do the Pythagorean theorem there, okay? Okay, let's see what else we got to do here. All right, now let's let v equal arc cosine of x. So I'm going to let v equal arc cosine of x. So that means then let's take the cosine of both sides. So the cosine of v equals, if I take the cosine of arc cosine, those cancel out, and I get just x again. And I'm going to do the same thing as I did with my up here. I'm going to make a right triangle and do the whole same business over here. And this would be v this time. So cosine is x over 1 because adjacent over hypotenuse. And now I want to solve for this side. That means x squared plus something squared equals 1 squared. So move the x squared over. So that'll be 1 minus x squared. All right. This is very nice because that means now we have a reference for what u is and what v is. All right. So let's go ahead and just straight plug it in right here. See, sine of u. Go to u. Sine is opposite of adjacent. So sine of u is just x. Cosine of v. I go to v. Cosine is adjacent over hypotenuse. So that's just x. Cosine of u. Cosine is adjacent over hypotenuse. So that's just the square root of 1 minus x squared. And sine of v is down here, which is opposite over hypotenuse. So that's the square root of 1 minus x squared. All right, so let's do a little bit of simplifying. X times x is x squared. Plus, now the square root of 1 minus x squared times the square root of 1 minus x squared. We have a principle that says this over here. If I take the square root of a times the square root of a, that's just going to be a. And that's just, and the reason why is because if I take the same thing, and then I'm going to get a squared. But if I take the square root of a squared, I just get a right there. So basically, I'm going to do that same principle where the square root of the same thing is just what's inside. So this is just 1 minus x squared. The x squareds cancel out, and I'm left with just uno. And just 1 is an algebraic expression. Again, it doesn't necessarily have to have variables in there, but what we did need to do is get rid of our trig functions, which we did. So our answer is just simply 1.